Thank you, guys. Thank you so much. Thanks, Louis. First of all, thank you for inviting me. Thank you for the kind introduction. Louis had sent me a message. Louis and Ravina had sent me a message before saying, you have to tell me a fun fact that I can introduce you with, and you have to have a song that would be an entry for you. So I figured I'll just say it myself over here. Fun fact is I'm a heavy metal fan. And my song for the introduction would have been Iron Maiden's The Trooper. But in the absence of having communicated that to Louis in before, we'll start here. So, what I'm going to be talking to you guys about is something that, we're all sort of thinking about, right? We've been thrust into this world where machines are now starting to do things that, we used to do all the time. And we're sitting here wondering what's going on, what's the deal. And what I like to sort of do is to sort of think about not just what the present looks like, but also what the future is going to look like. What is it going to look like not just 5 years from now, but 50 years from now? Are we ready for the kinds of transformations that, we're going to sort of encounter as we go, and what those transformations might be? Now, as you can see with the color of my hair, I've been around a long time. I have seen lots of different transformations in the industry. I started coding sometime in the 80s. And here I am, 40 years later, still sort of in the field. So I've seen a lot of transformations. I've seen sort of what sticks, what doesn't stick, and what sort of comes and goes. I was telling someone last night that the two things that have stuck for the last 40 years, C programming, functional programming. So, those two things, I have stuck with for the last almost 40 years. All right. So, what is the goal of this talk? More than anything, right, I'm going to present how I think things are going to play out. Now, you may or may not believe me. If you believe me, great. If you don't believe me, please discuss, right? I want this to be more of an inspiration to think about things and, maybe refine how we think as not just the community of functional programming, but also humanity as a whole. How are we going to deal with the challenges that are going to come across from all these technologies that are being developed? Okay. So that's my goal. Nothing that I'm going to say is gospel. So, take it with whatever grain of belief you want. But please ask questions. Let's discuss, and let's think about where this world is going. Okay. So, let me start with a show of hands. How many of you have used AI coding assistants? Well, that's a fairly significant number. How many of you have casually used it, by your function completion in your editor or whatever it is? How many have just casually used it? And how many of you have done projects where the entire project was done by AI? So, just a handful right now. But let's look at some actual statistics. Okay, so very popular very quickly. 72% of developers have actually used the tools. And in fact, this number was from last week. This week, the number is more like 82%. So a very rapidly spreading adoption of these tools. But as we saw from the show of hands, most people are using it sort of somewhat casually. They're not really using the tools to the extent that these tools have been designed for. Okay. This is a statistic that's sort of hard to believe, that this is happening right now today, especially if you reflect on your own programming experience. 25% of new code is written by AI, right? These are numbers coming out of Microsoft. They're coming out of various different, surveys. And it's sort of baffling that this so quickly, a quarter of our work we've just sort of given away to the machine. All right, do this for me, do this for me, do this for me. So what does the future look like? Is it going to be good? Is it going to be bad? Is it going to be ugly? Whatever it is, I think we need to think about it. We need to prepare for it, and we need to make sure that it's going in a direction that future generations of computer scientists, are coming into the industry with full knowledge of how things are going to shape up. Okay. There's sort of two things that we have to think about when we consider the future of technology in general. One is sort of the technical achievements themselves, right? How good is the technology? Is it going to get better? Is it, is it going to stagnate? Is it, what's going to happen? The second piece of it, which, usually as programmers we almost never think about, are the social aspects of technology. Now, technology has become so prevalent in our society, right? Everybody walks around with a very powerful computer in their pockets. So technology is sort of, inherent in our civilization today. So the social aspects of technology are equally as important to think about. What happens when technology and society are so tightly integrated? So we need to think about both of those things. Okay. So already we're starting to see, things that people worry about. Okay. Will AI take my job? It's a common sort of theme across, any white collar job today. This is especially important for developers. 49% of the developers actually believe that they will be replaced within 5 years. It's an incredibly high number of, and maybe they'll sort of figure out, oh, this tool is really not as good, and so maybe it won't replace me after all. Who knows? I don't know, right? I have some beliefs of, what will happen. But it's certainly things that people get concerned about, and this is sort of the intersection of society and technology. And how many of you are familiar with the Hollywood strikes? Okay, so I see a few hands. So just let me give you a context. A couple of years ago, I think it was, the Hollywood writers went on strike. And they went on strike because one of their demands was that the studios were starting to use AI to write their scripts. Right? And their whole claim was, look, you guys are just you're putting us out of a job. Right? Obviously, Hollywood is much better organized than developers are, but developers are in a similar situation today. What Hollywood did was the unions got it written into the contract that, they won't use AI for 3 years to cut out, AI jobs, to cut out writers' jobs. Will we have that in programming? I seriously doubt it. I don't think we're organized in that sense. But, maybe some social movement will happen. We'll get organized. There'll be the worldwide union of software developers. That's, doing contracts with companies. Who knows? That's the social part of it that we can, project, maybe. So let's, I have sort of 3 scenarios that I'm imagining, and this is sort of based on, today we start at 25% of lines of code written by AI. That's current statistic. The tool adoption is growing at 25 to 30%, compounded annual growth rate. So it's pretty rapid. Okay. So given that, we can imagine sort of 3 different scenarios. These are scenarios, these are not predictions, and these are sort of my synthesized scenarios, if you will. So, the first one is that the tools keep getting better. Okay? Now, as computer scientists, we all know that no tool ever gets worse. They just keep getting better and better and better, right? And they sort of reach some point of diminishing returns, but we haven't reached that with the AI tools. We're nowhere close. Okay. So the assumption is the tool's going to get better. The second thing is unbridled capitalism. Okay. We don't, like I said, we don't have a union of software developers. So, any company that's out there today is thinking, oh, great, this technology is 1,000 times cheaper than hiring an engineer. Let me see how I can use this. I mean, literally is 1,000 times cheaper. So unbridled capitalism will sort of make sure that more and more and more stuff is being fed through the AI code generation pipeline. Okay. The second scenario is, maybe the progress in tools sort of, evens out and doesn't grow as quickly as we would like. The third AI winter may be here. Who knows? I don't know. Maybe. But that's sort of the second scenario. And then we'll see some mild regulation, kind of like, we magically form a union of software developers and start negotiating contracts with companies. Who knows? So that'll slow down things a little bit. And let's say, so the number's up there, 90%. So 90% says 90% of the lines of code written will be written by AI. 60% number is sort of the mid-level scenario. And the really slow progress where the tools stagnate. I mean, they're not getting any better at all. And then there is strong government regulation across the world. And, only 40% of the lines of code in 5 years will be written by AI. Now, let me take a show of hands. Who thinks the first scenario is more likely? The first one. Okay, I have maybe 10% of the people. Second scenario. There you go, more likely people. And the third one. Okay, so it's a standard bell curve response, I have. So I actually believe that the first scenario is most likely. And this is just from seeing the energy that is being put behind this whole area, coming out of Silicon Valley and, all the companies over there and all the research work that's going on. The tools are going to get better, and Silicon Valley particularly is shamelessly capitalistic, and they are chasing down this biggest cost center that they have today. So this is happening right now as we speak. So, will there be ups and downs? Of course, there'll be ups and downs, and things will happen. What will sort of be mostly tending towards that top line there. And that's sort of the bet that I'm making. I've seen what you guys think about this, but this is sort of my bet. Okay. So if I start sort of assuming that the tools are going to get better, we're going to have more adoption, we're going to be forced to do more adoption, what does that sort of mean for us? Okay. So this is sort of the world, as from a very abstract perspective, I look at it today. Okay. So this whole world of small applications, things that you might carry on your phone, for occasional use. And then there's stuff in the large, which is stuff like the Google and the Ubers and really big complicated apps with tens of thousands of engineers. Now, the interesting part is that the people who are working on these things, if it's a small app, there's a small team working on it. It's a large app, there's lots of subcomponents and, very large teams coming together on those apps. But everybody has basically the same qualification, which is you're a skilled coder. Right? You're a skilled coder, you build something based on the skills that are necessary for building that application. Okay? Now, what the sort of progress in tools ends up meaning for you is that now for small applications, you don't really need a skilled coder anymore. You just need a skilled prompter. What I call you can be a technical specialist and build a small app very quickly, right? You don't have to be a complete newbie. You can be, aware enough of the tools, you know how to use the tools well. You can produce small things quickly. This is sort of analogous to, when the internet came up, there were people who were only specialists in HTML and CSS because all they did was quickly build web pages for small businesses, things like that. So there will be room for technical specialists who are not computer scientists in the full spectrum of things, but they are enough to build small applications. Okay? On the other side, however, what we're going to see is that we're going to be dealing with a lot more complexity, much larger projects, much broader in scope, but we're going to be doing it with much smaller teams. Okay? So the kind of people that you're going to need in order to handle this is slightly different. These are people who are going to be more broad-based. They're going to have to understand systems as a whole, and they're going to have to put everything together and make it work. Right? So this is the one that I'm going to be thinking about the most. Do we have enough of these people? Are we preparing our people enough to think about this? Right? How is this going to matter to a computer science student who's graduating, say in the next 5 years? Is he ready for this world? Is he or she ready for this world? And are we, as a community, as an industry, as a group of like-minded technical individuals, are we putting the right pieces in place for these people to think about when they come out? Okay. So, sort of summarize, right? AI coding tools in another 5 years will be good enough to do most things. Okay. When I say most things, obviously they're not going to be magical, doing every single thing that you can think about, but they'll be good at doing most things. There's a very high degree of competence. They're extremely competent even today. They do make lots of mistakes today, and that, is getting better by the week. Actually, every week sort of some new release comes out, and it's a little bit better than last week. And the scope of what is possible has also rapidly changed. It used to be that you used them to write a single function. Now you can use them to write lots and lots and lots of code. So that's just going to get better. Those metrics are just going to keep improving over the next 5, 10, 15 years. Like I said, it's 1,000 times cheaper, literally. What would have cost you $20,000 2 years ago will cost you $20 today, in raw numbers. Some would argue it's more reliable. The kinds of code that gets generated will be more reliable than is produced by humans. Who knows? Those are open questions still. Okay. And this is not assuming that we're going to have AGI, right? Not assuming there's artificial general intelligence. I'm just looking at the state of tools today and how much faster they're getting better. Okay. So, obviously this means, you worry about your jobs, you worry about, where the industry is going. It's also a worry for companies themselves, right? If you're a company like, say, Salesforce today, I have 10,000 engineers working on basically one product, and I charge $100 a user a month for it. Now, will some upstart with 3 people charge $5 for exactly the same service because they can build it somewhat cheaper, right? So as a company, my competitive advantage has also changed, right? And everybody is thinking about this. Everybody has to think about it. So if you're not, if you're highly reliant on large engineering teams, you have to sort of come back and think about what it means for you strategically. Okay. So what does it all mean? So I want to sort of start at the level of what does it mean to be an expert in whatever subfield of computer science you work in? We're all in this room, we're all experts in something, right? We've worked for something with X number of years. We understand sort of the totality of it, right? I sort of think about it like a hot air balloon, okay? First of all, you have foundations. Foundations are, things that we have learned about how to think about this field, okay? If you're a game developer, you think about how to use the gaming engine, but in the background, you know how the 3D rendering graphics works and, how you're going to make it faster and higher frame rate. There are all these sort of foundational things that you know about it. Then you have all the problem solving. The problem solving skills, honestly, is why we got into this field, right? All of us here. We love the problem solving. We love the challenges. We love solving those, daily challenges that come up. Okay, how do I do this? How do I do that? But most of our cycles, most of our time, most of our thoughts get consumed by the little things, what I call the arcana, okay? Arcane stuff that we are forced to remember, syntax of how things work. What is the Kubernetes command to do X, Y, and Z? Things like Kubernetes even exist. Why do I care about it? My head is stuffed with that kind of nonsense. Syntax, semantics, best practices, idioms, trade-offs, whatever they are. Right? Most of my time is spent in that big balloon over there. Okay. Here's what's happening though. AI is coming directly at that big balloon, right? That's what it's completely replacing. You don't need to know all this arcane stuff to do something. You just need to be able to specify it in a way that leverages these two things. Okay? I want a higher frame rate in my game. I know how I want to do it, but I don't have to mess with the C++ libraries, at the bottom because I can let AI do that for me. Okay? So, the air is going out of the hot air balloon. This is the number one impact that we're all going to feel. And if you're not seeing this, you're not using the tools correctly. Even today, you can do this. You can go to a completely new field, start programming in it, as long as you have these two, the foundations and the problem solving in your hands. Okay? And I would challenge you to go try it. You download Claude Code, which is my favorite coding assistant, and just program something new. Build an MRI machine. Right? Try it. You may be so surprised at how well you're able to do it. Okay? So, the slide isn't displaying correctly, but expertise gets redefined. Okay? We're no longer with, multiple hot air balloons. You don't need 10 hot air balloons to transport a whole bunch of people. What you now have is a high-speed aircraft with all the foundations that you need assembled together. Problem-solving skills are sort of taking you where you need to be, but AI is the 4 jet engines that are powering your airplane, right? So we're now heading to a stage where the foundations and the problem-solving are the most important portions of what programming is all about, which is, at the end of the day, it's bringing change into the world. And that's what programming is all about, at least to me. So, the arcana is irrelevant, and expertise is going to mean something completely else. Right? I don't need to hire a Kubernetes expert on my team anymore, which is, fantastic. But I do need to hire really good problem solvers, and you need to hire people who understand the fundamentals of the system, they understand the foundations. I can have them go and do whatever the hell I want, and they'll go off and do it because they have the right kinds of tools. Okay. So, the implication of all of this, one of the natural consequences, which I also alluded in my earlier slide, is that the complexity of what we're doing will go up. Okay. And this has been true of computer science for as long as I've been in it, and also before that as your tools get better, you learn to build more and more complex systems. Right? And, today we have millions of computers talking to each other, billions, I would say, across the world, and we're able to handle that complexity. And with the new kinds of tools, I think that's going to even get, bigger and bigger. I don't quite know what that will be, but I know that it will happen. Okay. So we're looking at a world where, as an engineer, as the deep system engineer that I referred to earlier, I have a much broader role. I have to design, build, and evolve very large, complex systems, and I have to do it with very small teams. Right? And when I say have to, it sort of ties back to the whole unbridled capitalism thing there. There will be startups that will come up with small teams that are competing with the very large players and building large complex systems. Right? So the people that we need to train and produce going forward are will have to grow into this role, which is much broader. Okay, but not only is it broader, it's also a much deeper role. Because I have so few people, I expect them to be good at all these things. And the reason I expect them to be good at all these things is because, as I said, they don't have to worry about the details of it. They have to worry about how they think about the whole system. How am I going to optimize the whole system at the instruction level all the way up to the user interface or the user interaction or even beyond that? Okay. And I'm expecting these people to understand the foundations of of the whole system. Okay. That's, it's a very different challenge. Computer science programs today are designed to produce skilled coders, right? Anyone who comes out of a computer science program today barely looks like this. They don't look like this at all. They look like, okay, I can do Python. That's sort of my skill set, and hire me for that. Okay. So we're going to have to rethink what we are teaching our kids today. Some of you are kids today, but I have to think about it. So given all of that, right? We're here, we're a group of functional programmers. Like I said, I've been doing functional programming since 1989. Miranda was my first programming language, functional programming language. I still think it's the most beautiful programming language I've ever programmed in, but I have become more of a Lisper now. Scheme, Racket, Lisp is my thing these days. So natural to think about, where does my field fit into this? Where does functional programming fit into this? Is it important at all? Is it just part of the big balloon of hot air that, I've been carrying around with me for 40 years? Is that where it's going to, just dissipate into the atmosphere and never have to look at it again? Is that the case? Okay. So let me try to think about that question a little bit. In order to think about that, let's sort of step backwards a little bit and look at the function that we have as human beings. And when I say function, I do not mean the functional programming function. As a human being, what do I do in this process? What is my job? Even if AI is there or not. What I do, especially, as I head up an engineering organization in my company, the three things on the left is sort of what I'm responsible for, right, as a human being. And you can break that down recursively, and that's true of, even the line engineers that work on small functions, small modules. They specify what needs to be built. They build it, and then they validate that the implementation is doing what it's supposed to do. So that human function is not going to change. We all do that on a daily basis. We do it on an hourly basis. We're going to have to do that, even that in the future. So this will never change. But its nature will change. Okay? Like I said, there's a social component to this. As a person who was selling a technical product to the market, I have a social contract with my customers, people who are buying things from me, that I am delivering to them a functional piece of software. That it works correctly, it will do everything that I've described in this data sheet. And I stand behind it. Okay? I turn around and I have a social contract with my engineer saying, I expect you to deliver this working piece of software to me so I can turn around and sell it. I have the trust that the engineers are trained properly, they have their skills, they have their problem solving, they have their foundations, and that they're going to build me something that I can stand behind so that I can turn around and represent it to my customers. But now, 90% of my work is being done by machine. I need to be sure that I can represent to my customers that I'm standing behind this piece of software. That this is not just, the software is going to do what it does, and I trust it, and I have that faith. Okay. Now, we all know about black boxes. We trust our compilers, on a daily basis. We never suspect compiler bugs. Anyone here ever caught a compiler bug? There's a few people. Yeah, you use them enough, you'll find them, right? But most people will never find a compiler bug, right? Big black boxes that we never look inside because we fully trust them, right? And our programming languages people have always been obsessed with correctness, and they do they put in lots of work to make sure that whatever they're producing is correct. I don't see that happening on average pieces of software, Yeah, if it barely tests, yeah, it works. I'm going to ship it, right? Much harder to do when a machine is doing it because you never know what's in there. You have legal implications, you have social implications. There's many things that happen when black boxes are doing your work for you. So, from what I can see, when I sort of roll the tape, the only way that I can trust that a machine has done its job is I have proof of correctness. Okay? And here's the sort of interesting part. AI actually can produce proofs of correctness. It'll produce a piece of code, produce a proof that your code is correct. Now, you have to verify the proof, hence you have a proof checker. But assuming that these two pieces are working in tandem, you can actually come out with a reasonable amount of certainty that the specifications that you provided have been met, and here's the proof of it. Or if they haven't been met, here are all the counterexamples. Here's all the issues that you're going to encounter with it. Right? And then you can take that whole package, the proofs, the data, the code, and say, look, here it is, it works, I can guarantee it because I have a proof for it. Okay. And this is where functional programming comes in. right? Some of you may have heard these names, Lean, Coq, Idris, Agda. These are all functional programming languages with dependent types. Dependent types are the ones that come with a proof checking system, or a proof assistant as they call it, that allow you to specify in gory detail what your problem is and how you're going to do it. And the proof assistants help you produce a proof that the program actually does what it's supposed to do. Okay? The good thing is, of course it's a pain to do that, right? Because if you've ever written a formal proof in the last 10 years of your professional career, then my hat's off to you. Nobody does that, right? But the AI can actually do it. The LLMs will generate a proof for you. And, they're still learning. They're still getting better. They're not fully there yet. But, I'm hoping that they'll get there. Now, functional programming is the most sort of suitable for this type of a framework where you're trying to get a guaranteed proof of correctness. Can't imagine doing that with Python. So, I have to do that with a language that supports the mathematical ways of thinking. So, I talked about dependent types and hybrid LLM plus proof checking. Now, this is work that has started already. People are doing that. They use an LLM to generate the proof strategy, and then they use a proof assistant to complete the proof. And they're starting to actually make a lot of progress in it. This is from a paper in, I want to say July.
This moment.
Reboot the
battery?
Yeah. I don't know.
Okay, so the provers are getting really better. These are sort of three commonly used benchmarks in this field of dependent typed programming languages. We're starting to see really high correctness numbers, 90% correct. These are the harder ones. These are sort of this is the Math Olympiad set of problems. This is the Putnam, the Putnam exam problems. So these are also starting to make sort of very rapid progress, right? So as these things get better in solving more and more complex stuff, we can start turning around and having the AIs and the LLMs actually do most of the work for us. So it's not unreasonable to expect a proof of correctness from your system, right? And I am sort of dying to be in a world where not only am I producing a program, I'm producing a proof of correctness of that program. That we haven't had that. It's been a pipe dream for many years, but now it's starting to come true. Okay. So, what does this mean for the students that we're training today? Okay. We're looking at a world where the most important thing that you need to know are the foundations of your system, of your field. The most important things that you need to learn are how to prove your programs correctly, how to do things correctly, and then you also need to be worrying about building whole systems, not writing code. Okay? You will be expected to build a whole system when you get out of school. And you will be expected to prove that whatever you built is correct. Okay. You have to emphasize mathematical foundations because you have to be able to prove things correct, right? You have to be able to stand behind what's generated. We don't teach with functional notation today. But if you believe that you're going to go into a world where the mathematics and the proofs are necessary, then you have to start teaching with functional notation today. everything, all the way from the hardware up, right, has to be taught with the functional notation, with the expectation that, there is a mathematical basis to whatever you're teaching. The specify, guide, validate methodology with AI, that has to be computer science 101. You have to be able to go in there, design something, prove that it works, and then, repeat the cycle. One of the things that I sort of, this is, you could call it a bit of a pipe dream also. This is my pipe dream. Mathematics has a fairly consistent notation across all the fields, right? If, whatever paper you pick up in math, you may not understand all the abstractions behind it, but the notations are pretty common, right? Sets are opened with curly braces. The dot is used to imply some sort of an operation, multiplication or otherwise, but sort of fairly consistent notation. Computer science, on the other hand, has a different notation for every damn subfield that we have. And it's one of those big, confusing things. Anytime you switch fields, it's like, okay, I'm learning this whole new set of notation all over again. Very problematic and very confusing. And sort of being the Lisper that I am, I sort of believe that notation should be Lisp, because it's the one notation that is so universal. It works for everything. You never need to learn a new notation ever again. Okay, I have 5 minutes according to Lewis, which is great because that was my last slide. So I want to leave you with one message. The future of AI coding is actually functional. And more of it, we should start to see as we go forward. So I will open the floor up to questions. Thank you.